Now let's take a look at the second group of molecules we're going to study, which are the alkyl halides. The kind of generic notation for an alkyl halide is Rx, where R is a carbon-containing group and X is a halogen atom. The halogens that we will encounter the most often are fluorine, chlorine, bromine, and iodine. An example of this would be ethyl iodide that I have shown here, CH3CH2I. I have the skeletal structure here. And in general, alkyl halides, of course, have this dipole between the carbon and the halogen. So there's a delta plus, delta minus charge distribution. And of course, the halogen itself has lone pairs. So you have sites of both potential electrophilicity as well as nucleophilicity in the alkyl halide group. In terms of intermolecular forces, of course, you're going to have dispersion between two molecules of an alkyl halide. Dispersion's always present in every substance, and remember that's that fleeting kind of electrostatic interactions that are constantly shifting and taking place on the surface of the molecule between the two molecules. But what you also have added here now, of course, are dipoles. And so in addition to the dispersion forces, you have dipole-dipole interactions. So for example, when these two guys line up, they actually want to maximize the delta minus, delta plus of one molecule interacting with the delta plus and delta minus of the other molecule. And so what we're looking at here, I'm going to change the color here. Here's the dipole-dipole interactions, because now we have, of course, delta minus, delta plus. And so this is going to be on top of the dispersion forces. So you have dipole-dipole interactions. So the bottom line here is that if you were, say, comparing a molecule of this ethyl iodide, so we have CH3CH2I versus just the hydrocarbon, so a 2-carbon chain with no iodide on there, you would expect that you would have a higher boiling point when there are dipole-dipole interactions present as well. Now keep in mind, you have to make sure that you're comparing approximately the same size and shape molecule when you're doing this type of comparison, because if this were a longer hydrocarbon chain, we couldn't directly compare it to something smaller, okay, because the dispersion will be directly affected by the size of the molecule and the shape as well. So alkyl halides can exhibit dispersion and dipole-dipole interactions.